Welcome back. This is lecture 5, talking about how do we connect sources together. I hope you have already watched my previous video that I discussed different types of sources, how we understand ideal and non-ideal sources, as well as time dependencies. In this taxonomy, the next step we have to talk about is how do we connect sources. First of all, why do we connect sources together? And what is the appropriate way to connect sources together? We have to be really careful. If you connect sources without keeping those principles we'll discuss into consideration, it's very likely that you will have an accident damaging the sources or potentially even injuring yourself. So it's very, very important to know how sources can be connected and cannot be connected together. In general, when we talk about connecting devices, there are many different ways we can consider, but in this class in particular, I'm going to focus on two main ways, which honestly are the two most common ways of connecting devices. One of them is called connecting devices in series, and an example is shown right here. And the other one is called connecting devices in parallel, and an example is shown right here. When we connect devices in series, we literally mean that we cascade devices one after another. That means that the ending node of one device, here is the ending node of device A, is becoming the beginning node for the next device. Similarly, the ending node of device B is now becoming the beginning node of device C, and so on and so forth. And here is the ending node of C that has just come the beginning node of A. So this back-to-back connection essentially means connecting devices in series. The real electrical characteristic that you should keep in mind when we talk about series connections is the fact that the current I is exactly the same for all of them. You really have one loop, you really have one current that flows here, and that's really the signifying characteristic for you as far as the electrical performance is concerned. The current I is identical for all three devices in this example. Let's now shift our attention to parallel connections. In a parallel connection, you are essentially grabbing all nodes of all devices, all the upper nodes, and putting them together into a single node. So this upper node for device A and this upper node for device B and this upper node for device C are all connected together. And similarly, you're grabbing all bottom nodes and you're now connecting them together to a single node as well. And because of that type of connection, essentially what we're ensuring here, or what we're forcing rather, is that the voltage drop V is identical for all three devices. The voltage drop V is right here, and that means that these devices do share the same voltage drop. They don't share the same current, as in the series case, but they do share the same voltage drop. So these are the two main ways, series connection and parallel connection, that you should keep in mind. Series connection means same current I, parallel connection means same voltage drop V. Now, let's see that with respect to connecting sources. One person might ask, okay, I have two different sources, 5 volts, 4 volts, two different voltage sources. Can I actually connect them in parallel and try to power a load? Now, you may ask this person, why exactly are you considering this? They may say, well, because this load requires more power than any of the two sources could give me, can I just connect them in parallel and ensure that I'm basically taking juice or power from each one of these sources? The answer here is a big and emphatic no, which I'm indicating with this red arrow here as graphically and as big as I can make it. Why is that? Because you have to go back and think about what a voltage source is really trying to do. The 4-volt voltage source is an ideal voltage source that is going to do everything in its power to keep the voltage across its terminal equal to 4 volts no matter what. That's its job, to ensure a 4-volt voltage drop across its terminals. But similarly, the 5-volt voltage source is also an ideal voltage source that will do everything in its power now to ensure that the voltage drop is 5. When you try to connect those two in parallel, essentially what you're doing is you're basically asking for the impossible. You're asking for the voltage drop to be 5 and 4 volts simultaneously, where obviously this cannot happen. Now you may say, well, this is a mathematical problem. I'm sure in real life, if I were to take two batteries, one at 5 volts and the other at 4 volts, and I were to put them in parallel, some voltage would develop there. Well, the answer is, again, please don't do it, because it's very likely that you will destroy at least one of the sources, and usually the weakest source will get destroyed. Essentially, if you were to attempt that in real life, what would happen is that the stronger source would essentially win that war. It would impose its own voltage on the other source, and the weaker source would be really unhappy about it. If there are no protections there, and if there is enough power from the stronger source, the weaker source at least would be burnt, and the resulting damage may actually cause a short circuit for the stronger source, so you may actually have everything damaged. If those are powerful enough devices, there could be fire, explosion, damage, injury. So again, never connect voltage sources in parallel. On the other hand, it's perfectly okay to connect them in series, as signified by the figure to the right. Well, why would you do that? Well, sometimes you need to give a particular voltage drop across a device. Let's say that we needed essentially a different voltage drop than 5 or 4. Well, it's entirely possible to basically connect a 5 volt voltage source in series with a 4 volt to basically get 9 volts across this device. So if you did not have a 9 volt battery, but you had two other batteries, 5 and 4, you could easily do that, and this is perfectly safe. The current that you would have flowing in this loop here will be determined essentially by the resulting voltage drop as well as the power of this load, and it will be safe to do so. Each source will be satisfied because each source will be creating the voltage drop it needs to, and therefore there is no issue. Exactly the opposite story is true for the current sources. A current source will always make sure that the current through it is its value, and if you were to put two of those sources in series, you would have a big problem because each source would try to impose its own current on this single loop. So that single loop, would it have 5 amps flowing or 4? Again, the stronger source would win at the danger of damaging the source or injuring the operator. On the other hand, connecting the sources in parallel is perfectly fine because each source would contribute 5 amps and 4 amps, resulting in a total of 9 amps flowing through the device, through the circuit, and therefore this is a perfectly safe connection. So that's the end of this video. Thank you for watching it. I hope you now understand why we connect sources together and when it's safe to do so and what connections are appropriate, series or parallel. It's a different case for voltage. It's a different case for current. Thanks a lot. See you next time.